So now we're recording. So everything we've done up to this point, we have been factoring trinomials, right? And up until now, plus bx plus c, we've been looking at trinomials where a was equal to 1, right? So that you just had x squared plus bx plus c. Now we are going to look at when a does not equal 1, when it equals something else. So if I had, for example, x squared minus 15x plus 36, we would know that we're just going to take the factors of 36 that add up to negative 15. And if you remember, we had a chart. It was like ax squared plus bx plus c. And we would know that these factors would be x plus something times x plus something else. And then if we had ax squared minus bx plus c, I'm going through this quick because it was in your Edpuzzle and your notes. We would have x minus something times x minus something else, right? This is what your factors would look like. And then you had ax squared, and it could be plus or minus your bx minus c. And you would have factors that were x plus something times x minus something. And depending on whether this was plus or minus is where your factor would go. If this was positive, your bigger factor would be positive. If your b was negative, your bigger factor would be negative. And that chart will still come in handy. And so for this, we would look at it and we go, okay, well, what are the factors of my c term, right? Factors of c that add to b, right? And that's what we were working at when we were doing it with a equals 1, right? So we'd take whatever 36 was, and we would take our factors of a that would add, our factors of c that would add to b, and we would have x minus something times x minus something, because we have minus plus, and here when we have minus plus, we have minus factors. And we would take all of our factors of 36, right, which are 1 and 36, 2 and 18, 3 and 12, right, 4 and 9. 3 and 12 add to 15, which is our center, and so we would use 3 and 12, right? This is what we've been doing. This is all last week's stuff. It's old news. But what if my a didn't equal 1? What if I had, first example, 2x squared minus 15x plus 18? Where would we go from there? Now, I have seen 8 million different ways to solve these kinds of problems. And I'm going to tell you right now, the way that I'm about to show you is the absolute easiest way. There is no way that's easier. You probably saw something in Algebra 1, maybe back in the day, where they used an x. This is so much easier. You're going to take 2 and multiply it times 18. And you're going to rewrite this without the 2. You're going to go x squared minus 15x plus 36, right? 18 times 2 is just 36. And now we're just going to solve it for this right here as though it was 1. What do we know? We know that we're going to have x minus something times x minus something else. Now, notice I chose the same problem that fit up here because we already know, right? Here are my factors of 36. We know that 3 and 12 equal our 15. And so I'm just going to put in 3 and 12. Here's the thing, though. We multiplied this times 18. So once we get those factors, once we've figured out those factors, we have to go in now and divide out that 2 that we multiplied by. We're going to reduce our fractions, right? 3 over 2 is not reversible, right? But 2 doesn't go into 3, so we're going to take this 2 and put it in front of the x. So this will become 2x minus 3. 12 divided by 2 is just 6. So we have x minus 6. I promise you, you will never find an easier way to do this, right? So you're going to multiply through, solve it as though it was a 1 in front, right? Just take the factors of your C term that add up to your B term, right? Figure out those factors and then put back in, divide back out that value that you multiplied. Let's look at this again with another example, because that was our first example. First examples are always sketchy. Second examples are where you start to make sense of it. So if I have 5p squared plus 22p minus 48, right? And I want to find my factors. What do I know? I know by looking at my chart, this is negative, which means I'm going to have a positive factor, a p plus something, and I'm going to have a negative factor, right? A p minus something. What am I going to work with, though? I'm going to follow the same rule. I am going to multiply whatever this a term is times my c term, right? If you don't know what 5 times 48 is off the top of your head, fine, use a calculator to tell you what 5 times 48 is, right? I don't care if you know that right off the top of your head. You're going to rewrite the problem as p squared plus 22p times whatever 5 times 48 is. And in this case, it's 240. Remember what you multiplied by. We multiplied by 5. We are going to have to divide out that 5 at the end. But now we're just looking for these factors, right? The p plus something times the p minus something that's going to work with the factors of 240. So I'm going to look at what are my factors of 240. It's a big number, right? What do I know? I know that one's positive, one's negative. I know that the bigger one is positive because this is positive. So I'm going to go negative 1 times 240. I'm going to go negative 2 times 120. I can look at all my factors, right? Negative 3 times 80. Negative 4 times 60. Negative 5 times 48. If you know them fast, fine. If you can automatically figure out what it is, fine. But if you can't, that's all right too. Just go through all your factors. Negative 6 times 40. Negative 7 doesn't work. Negative 8 times 30. Well, 30 minus 8 is 22, so I found my factors that work, right? 30 minus 8 is 22, and that's the number we're looking for, right? If I tried this one, I'd get 239. If I tried this one, I'd get 118. If I tried this one, I'd have 77. If I tried this, I'd have 56. If I tried this, I'd have 43. If I tried this, I'd have 34, right? But 30 minus 8 is 22, and that's what we're looking for, right? So I'm going to write these in. Where my negative one is, I have 8. My positive one is 30. And now we have to put back in the 5 that we took out. So we look at this and we go, okay, well, 30 divided by 5, that's just 6. That works. So p plus 6. 8 is not divisible by 5. They're not reducible. Like neither of them they're not both divisible by 2. They're not both divisible by 3. They're not both divisible by 4. We don't have anything that divides into them. So we're going to take the 5. We're going to put it in front of the p. And we are going to have 5p minus 8. Ooh. Does that make some sense to you? Yes to Alfonso. How about Liliana or Adriana or Gracie? I could wait all day for them to answer me. All I need is a yes or a no. Are you even there? There we go. I got Adriana's here. Okay. Someone's calling me. So let's look at another one that's a little bit different, right? What if I have um 12x squared plus 5x minus 2. We're going to follow the same steps, right? We're going to take, just wanted to be big there. Now it wants to be small. We're going to multiply the 12 times negative 2, and we're going to rewrite the problem. Now it wants to be tiny. It cannot make up its mind. Every time my hand touches it, I'm left-handed, so it's really hard for me to write on these tablets because every time my hand touches it, it wants to change things. So I'm going to multiply 12 times negative 2, and I'm going to rewrite the problem. I'm going to have x squared plus 5x times 12 times 2, so negative 24, right? 12 times 2 is negative 24. We're going to keep in mind that 12 is what we're going to have to divide back out later because that's what we multiplied in. And when we're factoring these, we're going to take our factors of c, our c value, which is 24, that add up to 5. What do we know about them? We know that we're going to have x plus something times x minus something because we have an end term that's negative. We know our bigger one will be positive because this is positive. So let's look at our factors of 24. We've got negative 1 times 24. We've got negative 2 times 12. We got negative 3 times 8. I know that's the one that works. I could keep going though. Negative 4 times 6. Negative 5, right? 6 times. 8 minus 3 though is 5. So we know that this one, this set right here will work. And so our 8 is positive, and our 3 is our negative. And now we found those factors, but we have to put that 12 back in, right? Or technically divide it out. So I'm going to go ahead and reduce these fractions. If I look at this first one, everything here is divisible by 4. So I'm going to go x plus, well, 8 divided by 4 is 2. 12 divided by 4 is 3. So now I have x plus 2/3, right? Here, everything's divisible by 3, so I get x minus 1/4, right? 3 divided by 3 is 1. 12 divided by 3 is 4. So I've got that. Now these are completely reduced fractions, right? I can't make them any smaller. And since they don't create a whole number, I'm going to take the denominator here and put it in front of x. And I'll have 3x plus 2. And I'm going to take the denominator here and put it in front of x. And I'm going to have 4x minus 1. So That's about as simple as I could make these. And I'm not asking you to solve them. I'm not asking you to set them equal to 0 and tell me what the solutions are, right? We've done that. We could do it again if we wanted, but we don't have to. We just want to know what the factors are right now. And this is as far as we need to take it. I have one more example for you, right? We'll call it example number 4. I'm going to have 16m squared plus 60m minus 54. When I look at this, I could, if I wanted to, I could multiply 16 times 54 and figure out what all those factors are, and it would work, but it would be a pain in the butt, right? Because I'm going to be dealing with a huge number, because 16 times 54 is really large. But I see that all of these are even numbers, so I know I could at least factor 2 out of everything, right? So I'm going to go ahead and do that. I'm going to start by dividing everything by 2, because then my factors will be the same. 16 divided by 2 is 8m squared. 60 divided by 2 is 30m. And 54 divided by 2 is just 27. Now, like I said, if I wanted to, I could multiply 16 times 54, but then I would have to find all the factors of what 16 times 54 is. And I believe that's somewhere in like the 600 range, right? If I looked at, let's see, what is 54 times 16? Clear. 16 times 54 is 864. So I would have to find all the factors of 864 until I found one that added up to 60. But if I do it this way, I only have to find the factors of whatever 8 times 27 is, which is 216. So I no longer have to deal with such a large number. And yeah, I'm still dealing with a pretty big number, but it's not nearly as large. And I don't have to think about this 2 anymore, right? I'm going to rewrite the problem multiplied 8 times 27. So I'd have 2 times m squared plus 30m minus 216. And it is a lot easier to find the factors of 216 than it is to find the factors of 864, right? What did we multiply by? We multiplied by 8. So we want to remember at the end that we have to divide the 8 out. I always kind of write it to the side. What are our factors going to look like? They're going to be 2 times, well, m plus something times m minus something. I know that because this is negative. And now we're going to look at what are our factors of 216 that add up to 30. So I'm going to go negative 1 times 216, negative 2 times 108. Does 3 work? Yes. I know 3 works because if I add all these digits together, they equal 9, and 9 is divisible by 3. Negative 3 times 72. I also know it because I wrote down all these factors earlier so that I wouldn't have to be figuring out what the factors were. Times 54. Negative 6 times 36. Ooh, if I look at that, 36 minus 6 equals 30. So we're good there, right? This is as far as we need to go because we found the one we want. So here at my negative, I'm going to put in 6. Here at the positive, I'm going to put in 36. What do I have to divide those by to get the actual factors? what did I factor out in the beginning? What did I multiply times 27 to get that 216? Look up here. Right? I appreciate you taking some guesses. But what did I multiply by? I multiplied 8 times negative 27 to get it. So I have to divide out the same thing. I have to divide by 8. Right? So when I go to reduce these fractions, I've got 2 times, well, 36 divided by 8. Does 8 go into 36? No, not evenly. But we can reduce that fraction, right? Each of them are divisible by 4, right? So if I have m plus, well, 36 divided by 4 is 9, and 8 divided by 4 is 2. Here I have m minus 6/8. They don't go into each other, but they're each divisible by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Now what do I do? Anyone remember what I do with the denominators once we reduce the fractions? Perfect. Yeah, we're going to move it out to the front. Alfonso got that. So we've got 2. That's going to stay the same. We're going to take this 2 and put it in front of the m. 2m plus 9. This one, right, we're going to take this 4 and put it in front of this m. And we'll have 4m minus 3. And that's our final answer, right? If I wanted to, I could multiply these through and show, right? I better come up with the same initial equation that I had so we could see if we were right. But we don't have to do that right now for the purpose of keeping our video a little on the shorter side. If you have any questions when you're doing the homework, make sure and go through the video to the point where you're stuck, right? And then you can see all of the sample problems and how they work.